Hi guys, let's look at the review packet for our last proficiency target. Not the accumulative knowledge one. Our proficiency target number 3. Use math and computational thinking and can correctly use equations to calculate emotions and objects' motion. So, I think we should look at the last 3 questions together on that review for that particular proficiency target. And recognizing these equations that we're talking about are on your reference sheet, and they're these ones right here. Okay. Now, for every single word problem that you approach, I want you to follow the same method that we've been talking about in class. I want you to draw a picture, establish an origin, make your list of knowns and unknowns, and then find the equation that you know everything except for that unknown that you're going to solve for. So let's practice this technique. A car accelerates at a constant rate from 5 meters per second to 25 meters per second, while it travels a distance of 225 meters. How long does it take to achieve this speed? Okay, let's make a small change here. I should have changed that before, and I'm sorry. Let's make this 2 sig figs instead of just 1. So let's change that to a 5.0 meters per second. Okay. Alright, so with that established, we got 2 sig figs, 2 sig figs, 3 sig figs. When I read a problem, I like to underline the info that I think is important, like it's accelerating at a constant rate, and it's going to go from 5 meters per second to 25 meters per second. And while it travels, it's going to go a distance of 225 meters. And then a part that students always forget, how long does it take? Meaning, like, that's my unknown. That's what we're wanting to solve for. So I have a car, right? A car, and it's going down the road, and it's starting at 5 meters per second. It's going to accelerate to a velocity final of 25 meters per second, and during that time it covers 225 meters. Like, it starts here, it ends all the way over here, and that distance from where it started to where it ended is 225 meters. I'm going to choose this direction to be my positive direction, and I'm going to say the car starts at the origin. I'll make that my 0 meters, and so this would be 225 meters. Okay, so I drew a picture, I established an origin, and now I'm going to create a list of knowns and unknowns. And I highly suggest that you adopt the same list, and so that when you approach any problem, you go, okay, I have x initial, x final, velocity initial, velocity final, acceleration, and then time initial and time final. If you give yourself the same list each time, it's okay if we don't know certain components of it, but it gives you a clue, an indication that you should be looking for these things. Like x initial, it doesn't say it up above, but according to our drawing, we are starting at the origin, so that would mean I'm starting at 0 meters away from my origin. I'm starting at my origin. X final, I end 225 meters away from my origin. My initial velocity, which was in the problem, 5 meters per second, and my final velocity will be 25 meters per second. Okay. It's a constant acceleration, so this is not going to be like final minus initial. That's not going to change. It's going to be the same the entire time. Time initial, well, right here, that's when I started my stopwatch, and that moment that I hit the button on my stopwatch, it read 0 seconds. I want to know how long it takes, So that's my unknown. That's what I'm solving for. I drew a picture, I established an origin, I made a list of knowns and unknowns. There is a component here that I don't know, and it's not my unknown, and that's okay. I just need to pick an equation that does not include the acceleration because I don't have that information. So here's our physics reference sheet. This upper left-hand corner, those are the equations that I'm working with. So I'm going to look at these, and I'm going to determine if it's a viable equation that I could use to solve this problem. So the first one here, this is a velocity average, meaning like a continuous velocity. And my velocity is not the same throughout, it changes. So I can't use this one. Acceleration, oh, I don't have acceleration, so I can't use that equation. This again is a constant velocity. This velocity doesn't say final minus or initial. So because my velocities are changing, I can't use that equation. Velocity final, velocity, oh, I don't have the acceleration, so I can't use that one. Same here, same there. Now let's look at this equation. I know my x final and initial. I know my velocity final, I know my velocity initial, and I'm going to be solving for the time. That's my unknown. So I know everything in this equation except for my unknown, and that's why I'm going to choose this equation to use. Often you can use more than one equation, like there's more than one viable option. In this case, we only have one equation on our list that we're able to use to answer this question. So I'm going to write that equation up above. Delta x, remember delta means final minus initial. Delta x is equal to 1/2 velocity final plus velocity initial multiplied by t. Now when t is by itself in an equation, you can make the assumption that it is t final and that t initial was 0. Okay. All right, here's my equation. I'm going to check it one more time. I need to know everything except for what I'm solving for, my unknown. I know this, I know this, I know this, I know this, and that's my unknown. So I know that this is an equation that I can use to get a correct final answer. Now let's see. Looking at my list, x initial is 0. So that component's going to be 0. Everything else is good. T initial is 0, but it's not part of this. So I can rewrite this equation, and I can drop that component because it's 0. X final equals 1/2 velocity final plus velocity initial multiplied by t final. 1/2 and t final, well, 1/2 and velocity final plus velocity initial, all of that is multiplied by t final. So to isolate t final, I can divide both sides by 1/2 velocity final plus velocity initial. So what I'm left with is x final divided by 1/2 velocity final minus velocity initial. Dividing by 1/2 is the same as multiplying by 2, so if you wanted to, you could replace that as 2 multiplied by x final, or you can leave it like this. Either way is fine, and this all equals time final. Okay. I chose my equation, I rearranged it to solve for my unknown, so my last step is going to be solving for my final answer. I need to solve both my units, I need to solve for my final units, I need a unit analysis, and I need a numerical answer. On the exam, if you rearrange an equation, you are required to do a unit analysis. So let's practice that here. X final is in meters, and I'm going to divide that by 1/2 is unitless, velocity final, which is meters per second, minus velocity initial, which is meters per second. Okay, so my units, I'm taking x final, which is meters, and I'm going to divide that by meters per second minus meters per second. And then I'm just put that over 1 so that I'm dealing with two fractions here. Meters per second minus meters per second is just meters per second. So this would be like m over 1 divided by meters per second. And whenever we divide by a fraction, that's the same as multiplying by the reciprocal. And when two fractions are multiplied, it's essentially one big fraction. So if mass is on the top, or sorry, if meters is on the top and the bottom, then it can cancel. So units, I'm left with seconds over 1, or seconds. And that's good because what I solved for was time final, so I'm really glad that I have units of time. And this is a great indication that I rearranged this equation correctly. Now that I know my unit, let's get a numerical answer. Since I've made a list of knowns and unknowns, I don't need to rewrite all this with the numbers in there. You've already told me that x final equals this and velocity initial and final equals that. And so I don't need to rewrite all that again. I can plug it in my calculator. Now, if you do not include your list of knowns and unknowns, then you do need to communicate to me what you mean by x final and velocity initial and all that. So x final was 225 meters divided by 1/2, which was multiplied by velocity final, 25, minus velocity initial, which is 5. Okay, so x final divided by 1/2 multiplied by velocity final minus initial. Oh, did I lose track? I'm so used to writing final minus initial. Look, it's plus, not minus, right? So let's change that. Plus. Okay. Looking at my list of knowns and unknowns, other than my zeros, I have 3 sig figs, 2 sig figs, 2 sig figs. So I'm going to get a final answer of 2 significant figures. So I will round that up to 15 seconds. All right, on to our next problem. Let's see, where are we at timing-wise? Yes, okay, there's only a couple minutes left in this recording. Let's set up this one, and then we'll solve for it in the next video. Okay. A motor scooter starts at rest. So it starts at rest, speeds up at 3.5 meters per second squared. That unit's a good indicator to me that this is the acceleration after the traffic light turns green. How far, that's my unknown, how far will it have gone when it's traveling 25 meters per second? All right, so I'm going to have a scooter, and it's going to be speeding up. So we have our scooter, and it's going to be speeding up. I'll say it's going to go into the positive direction. I'll call that positive direction. And where it's starting on this journey at rest, I'm going to call that the origin. So I drew a picture, I established an origin, and now I'm going to make a list of knowns and unknowns, and it's that same list. X initial, X final, velocity initial, velocity final, acceleration, time initial, time final. And again, this is, if I can repeat this list, if I can bring it up each time, then that's a good indicator to me to remind me, oh, do I know this value yet or do I not? Like X initial, I'm starting at the origin, so that would be 0 meters. How far will it have gone? So X final is what I'm solving for. It started at rest, so velocity initial is 0 meters per second. how far will I've gone?